We finished domain and range, which is a really big skill. Like they put it on every single test, every single state test. So yeah, you'll see it moving forward in every unit, every math class, and so forth. So it's better to just kind of have a good understanding now or ask questions as well. But basically, you need to know that domain refers to all the what of a function. All the inputs, x's, independent variable, whatever you want to call it. So now it's just like another synonym. Domain is asking you what all the x's are of a function. And then the range is all the what of a function. And what's an easy way to remember that? Okay, good. I know it's like weird, but you'll never forget. Because there's no really other way to like remember it. Like domain is a random word. Range is a random word, but domain is all the x's, range is all the y's. So in any situation, you got to figure out basically what would be the x, what would go on the x-axis, what is independent. So usually time, not all the time, but usually time, numbers of something, like number of campers earlier we saw, something that can't be changed by the other variable. So whatever the other variable is would go on your y-axis and be your output. That depends on whatever your input is. So like the revenue from the camp depends on how many people sign up for the camp and so forth. And then you got to go from there, see what's reasonable, what's unreasonable for each. Okay, so you have 2 practices to help with that. 80% or higher on both. I know one of them is only 3 questions. I still want you to try to get 80% or higher on it. So if that means you got to get 100% on it, then that's what you need to do. And I will happily delete your lower submission until you do that. Granted, I don't want you just to guess. So please, like, each time try. And then if you still aren't reaching that 80% threshold, maybe ask. Because occasionally there are errors on the key. Not lately, it seems like, but occasionally there are errors, or it just might be like some key thing that you're not understanding that I can fix in a little conversation. So do that, 80% or higher on both, and then after that, I'll give you the freedom to do what you want, whether it's getting your grades up, whether it's doing the study guides, whether it's work for another class, whether it's just being on your phone, but these need to be 80% or higher. I noticed yesterday, like, there was 2 as well. Some of you did one of them and then just half. You gotta do them both. 80% or higher on both. Questions? Okay, so then I'll leave you to it. Please let me know if you have questions.
Number 2 on lesson 10 says a rectangle has an area of 24 centimeters squared. The function f gives the length of the rectangle in centimeters when the width is w centimeters. Choose all of the possible inputs. So the 2 variables, it's always up to me when I kind of make an axis and label them. So if I was making a graph, it looks like we're comparing length of a rectangle and the width. So okay. So when we are talking about possible inputs, it could either be the length or the width. They're kind of the same, honestly. They'd be interchangeable, length and width. Which one of these could not be a measurement of a length or width? Okay, good. Then also zero is kind of hard, like whether to include it or not. Oh, and it's all the possible ones. Maybe I shouldn't select that. Maybe I should exclude that one. But 0 is kind of difficult because obviously if you're measuring something, you probably don't have it at 0. That one just kind of hit or miss, whether they include it or not. But then also see this kind of limitation. So if my area is 24 centimeters squared, how do you find area of a rectangle, by the way?
area of a rectangle is length times width. So we don't know what the width is, they're not giving us a value, but they are giving us what the area is. So whatever this L is, has to be able to be times by something to get 24. So could I times 3 by something to get 24? Yeah, so I'm gonna pick the one that says 3 centimeters. Could I times 0.5 by something to get 24? Okay, well, it's like 0.5 times 48 maybe? Let me just double check that. 0.5 times 48 does give me an area of 24, so I would pick that one. 48. Could I times 48 by something to get 24? Well, not a negative, because then my area would be negative, and that's not possible. But didn't we just do that right here? What did we times that 0.5 by to get 24? So then couldn't I also times 48 by something to get 24? And then, but I times 0 by something to get 24. So then it's just these three. Right, these are all that are possible. The areas length times width, you're thinking, what can I times by some number to get 24? Okay, any other questions? It could be from anything. We even have the study guides available for unit 4 too. Starting to help with that. The next one. Someone's calling me, I'm missing that. Number 3.
Same practice, but number 3. So select all the possible input output pairs for the function y equals x cubed. All right, so you could do a few things. One thing you could do, which may or may not be easier, is you could type this into Desmos and then see if each of these coordinates were on the line. Because then if they were, then they would be input output pairs for the function. This equation isn't too bad though. We could also do it by hand, or we could still use a calculator for the math part. But inputs are all the what of a function? X's, and these are all in coordinate form. So if I plug in all the X's and I get whatever they're paired with for the Y, then that is a possible input output pair. So like, let me try the first one. And anytime you plug stuff in, use parentheses. So they're saying that Y is -1 and that X is -1. Now, when you are cubing something, what are you actually doing? Okay, good. Exponents tell you to multiply the base by itself that many times. So really, this is me multiplying -1 by -1 times -1. And if you remember our integer rules for multiplying, your answer is going to be positive or negative depending on how many negatives are being multiplied together. So if there's an odd number of negatives, then your answer is going to be negative. If there's an even number of negatives, your answer is going to be positive. So what's my answer going to be? Positive or negative? Negative, because I have 3 negatives. And then what's 1 times 1 times 1? So this is correct. I am going to pick this one. It did give the right output for that. Then that's what you're doing for all of them, essentially. So I'll also show you at the calculator too. But for the next one, we're going to see if when I cube a -2, if I get a +8. Well, knowing what we know, should my answer be positive or negative? Negative. So I'm not even going to put that in my calculator. It would actually equal a -8, not a +8. This one, if I cube a 3, do I get 9? No, I get 27 actually. 3 squared is 9. So don't pick that one.
This one I'm for sure gonna need a calculator, because I don't like to get that. But, yeah, anytime you use a calculator. And you're plugging something in, use parentheses. So in that one, we're seeing if 1/2 cubed is 1/8. So. Half in parentheses. That one. And then we're gonna see this. Okay, now give me a decimal. If you want the fraction, press this button. Is that 1/8? So then we are gonna pick that one. Next one, if I were to cube a +1, would I get a -1? All right, no, there's no negatives involved at all, right? 1 times 1 times 1, so don't pick this one. And then last one, if I cube a 4, do I get 64? So let me do that one in my calculator. All right, I do get 64. So then those are my possible input output pairs. See if it's right. Okay, yes. All right, so whatever equation it happens to be, you could just use a calculator and just input it and see if it gives you that output. But that one was pretty easy, so we could do some of it like that. Questions on anything else? Study guide, practices. You let me know.